Alright, so welcome back to the final video where we check the final function, the one that gives a 33% boost. And here it is. The most dumbest things ever, right? So the reason why I didn't think about that right away is because usually you can easily avoid simple branches by doing this kind of multiplication, right? Where you multiply by the value, since one of the condition is going to be 0, you only pick one value, right? Which is basically the same thing that we did to build the mask. The reason why I didn't do it right away is because in my head this kind of branch was too complex, because I was doing different things based on the value. I was doing multiple things and different things. So I said, in my head I was like, no, I need to use AVX so I can select in the register and blah blah blah, which was bullshit, right? But the first step to get in the right direction was realizing that converting everything to an addition, first of all, like, made my life easier, all right? And second is that I could do the same exact thing, but rather than be just 2 multiplication, it's just 3, and I perform that for both the u and the v, right? So you see that I'm basically executing the code of all the 3 branches and storing the result directly. So after I computed which one is the lowest, right, I just basically extracted the first line, so u plus uv offset by multiply the uv offset by the condition. So if it's right, this value is going to be added, otherwise it's not. Then I grab the offset for the second branch and I add it by, of course, masking it by the condition, and same for the third branch. Same for the UV, and I write it down, right? And that basically avoid us all the mess we did, loading into the AVX register, do the store mask and all this kind of crap, boil down to simple, super quick addition and multiplication, all right? And written down to the output memory directly, and that's why it's faster. We're just doing less work, less complex work, and it's much more simple. And you can see that it gave us a 33% boost. So nothing magic about it, and you know, usually the biggest optimization is basically don't do code that you don't need. And you can see the whole thing's boiled down to a really simple thing, but nonetheless was an interesting exercise. You saw 3 different ways to achieve the same thing. So the first implementation, a naive one, the 5% one, I don't see when it can actually be useful because it's just slow. The second one actually can be really useful if you are already into an AVX environment. If you're already AVXing your code heavily, it might be something you might want to do, basically building this mask to mask out specific values and compact them on the right of the register. So that's it for final video of this mini series. I hope you enjoy. Any comment and feedback is more than welcome. See you in the next one, guys.